Yes, my dear students, today I would like to discuss about Unit 2, Principles of Quantum Mechanics. In Principles of Quantum Mechanics, basically the phenomena like interference, diffraction, polarization of light, etc. are explained on the basis of the wave nature of light. On the other hand, the photoelectric effect, Compton effect, etc., are explained on the basis of a particular nature of light. The radiation or light waves in the dual nature, both wave and particle nature. The concepts of dual nature of radiation can be understood by knowing the relation between the particle and as well as the wave nature of the characteristics. But generally, a certain amount of quantum occupies a certain space, then it becomes the particle. The particle has mass as it is occupied a certain space. The position can be identified. Then its position changes. Then it has velocity. Due to the mass and velocity, the particle has a momentum and energy. Some of the characteristics of wave and particle explained later. So what are the concepts of principles of quantum mechanics? Introduction to quantum physics, wave particle duality, de Broglie's hypothesis, Davison and Germer's experiment, Eisenberg uncertainty principle, physical significance of wave function, Schrodinger's time independent wave equation, particle in a one-dimensional potential box. The first one is the introduction of quantum mechanics. There are a few phenomena which the classical mechanics fail to explain the stability of an atom. And number two, the spectral series of hydrogen atom. And number three, black body radiation. In era of 1900s, Max Planck, a meeting on German Physical Society, read his paper on the theory of the energy distribution law of normal spectrum. This was the start of the revolution of the physics, that is, the start of quantum mechanics. Quantum means wave packets. So in the beginning of 19th century, the study of energy distribution in the spectrum of black body radiation becomes insoluble. The classical or as well as Newtonian mechanics fail to explain it. Hence, in 1900s, Max Planck explained the spectrum of black body radiation with a new theory called quantum theory. In Greek, quantum means, in the Greek language, quantum means a discrete or integral or whole. From the 1901 onwards, quantum theory becomes a major part of physics to explain the number of problems like Bohr's theory, hydrogen atom, and hydrogen atom, hydrogen spectrum, and photoelectric effect, Compton effect. So in quantum theory or quantum mechanics was developed mostly between 1900s and 1930s by European physics scientists, including Max Planck, Einstein, Niels Bohr, de Broglie, Max Born, Dirac, Paulus Dirac, Eisenberg's, Pauli, Schrodinger's, and Richard Feynman. So quantum mechanics, it is the generalization of classical physics that includes classical law as a special cases. Quantum physics extends that range to the region of small dimensions. Just as a velocity of light signifies universal constant, the Planck's constant characterizations to the quantum physics. The Planck's constant, the value is h is equal to 6.65 into 10 power minus 27 x seconds, and it converts the joule seconds 6.625 into 10 power minus 34 joule second. So the nature of light is a dual nature. One is a particle nature, another is wave nature. So light is a form of energy, and the energy can be transported in the space in the two ways. One is the particle nature, another is a wave nature. The velocity of the light from a small source follows the inverse square law. So the particle tends to move from one place to another place. The moving velocity is v. That means, so this is a particle. The particle is a definite mass m, and the particle moving from one place to another place. The small distance is v, and the velocity is v. The moving particle is associated with a wave. It is a de Broglie wave. That is the momentum of the particle. P is equal to mv, and the kinetic energy K is equal to half mv square. So that is called the particle nature. And the wave is, it is not a located region. It is spreading from the throughout the all the regions of x-axis, y-axis, and z-axis with respect to time period. Difference between wave and particle duality. So the particle has a mass, and it is located at some definite point. It can move from one place to another place. It gives energy when slowed down. The characteristics of particle is, it is a mass m, and velocity is v, and momentum p is equal to the product of mass into velocity, and energy is equal to half mv square, the kinetic energy ke. These are the characteristics of particle. And wave is, the wave is spread out over a relative large region of space, and it cannot be set to a particular location. It is spread out by its a frequency nu, and wavelength is lambda, phase phi, amplitude is a, and intensity. Now, these are the characteristics of particle and wave. So wave and particle characteristics is, number one is the particle characteristic, mass m, velocity is v, momentum is p is equal to mv, energy is half mv square. At the frequency, wave is a frequency, nu, wavelength lambda, phase phi, amplitude is a. This is called light duality of the particle and wave nature. So what is the de Broglie's hypothesis? In de Broglie's hypothesis, in 1924, de Broglie says light has a dual nature. And de Broglie put forward a hypothesis which states that the radiation behaves as a particle under some situations and the wave in the certain situations. Then matter also exhibit both type of nature, particle nature and wave nature is called dual nature of the light. So the waves associated with the matter is called the matter wave, or the moving particle is associated with a wave is called de Broglie's wave or matter wave. De Broglie derived an equation for the wavelength of matter waves from Einstein mass energy relation. and Planck's radiation theory. According to Planck's radiation theory, the energy of each atom, each photon is given by E is equal to h mu. That is, E is equal to h mu. This is called equation 1. And according to Einstein mass energy relation, E is equal to h nu. E is equal to mc square. Mass energy relation, E is equal to mc square. From 1 and 2 equations, we find h nu is equal to mc square, where h is the Planck's constant, frequency is nu is equal to c by lambda, m is the mass of proton, c is called velocity of proton. So h nu is equal to mc square. That means h nu is equal to mc square. Then hc by lambda is equal to mc square. Here, since nu is equal to c by lambda, then c cancel. Lambda is equal to h by mc, where c is the velocity of the light. Velocity of the light is converted to momentum of the particle, that is called h by p. So that is called h by p. So that is called the de Broglie's hypothesis, equation of momentum of proton, and it can be written as, in the same way, if the electron with charge is E and mass m moves with a velocity v under a potential difference is v, therefore lambda is equal to h by mv, that is equal to h by p. So this is called the de Broglie's hypothesis. Then you will calculate the de Broglie's wavelength associated with the proton wavelength. Then E is the kinetic energy of electron in a potential field. E is equal to small e and capital V volts. Kinetic energy of electron is of m v square. Of m v is a velocity of m v square. Therefore, from these two equations and simplification, from E is equal to EV, E is equal to of m v square, both must be equal. In this equation, left hand side, right hand side, it multiply the small m value. M EV is equal to of m v square, of m square v square. So that means m square v square is equal to m square v square is equal to 2m EV. So m square v square is equal to this side 2m EV. M square v square is equal to 2m EV. In mv is the momentum and m square v square is momentum square. That is m square v square is equal to p square. The p square is equal to 2m EV. Therefore, p is equal to root 2m EV, where v being the voltage applied on the electron. So, in the equation, so m is a mass of electron, E is a charge of electrons, and volts. These values substitution and simplification. So, therefore, lambda is equal h by root 2m EV root. So h is equal to 6.625 into 10 power minus 34 by root of 2 into 9.1 into 10 power minus 31 is the mass of electron value, and the charge of electron is 1.6 into 10 power minus 19, and V is a potential volts. And these values, substitution and simplification, finally get at the value, that is the lambda is equal to 1.227 into 10 power minus 9 by root V nanometers, and lambda is equal to 12.27 by root V angstroms. So this is called de Broglie's associated with electrons wavelength. 12.27 by root V angstroms or 1.227 by root V in 10 power minus 9 nanometers. That means nanometers means 10 power minus 9 is nanometers. So that is the value. So properties of matter waves. The properties of matter waves here, lambda is equal to the de Broglie's hypothesis, lambda is equal to h by mv. So lighter the particle. So mass of the particle is a smaller or lighter and greater wavelength associated it. Greater wavelength. So greater wavelength means it is lambda is inversely proportional to mass of the particle. If the particle is smaller, the wavelength is longer or greater. And smaller the velocity of the particle, greater the wavelength associated with it. When v is equal to 0, the v means the velocity of particle. V is equal to 0 and the corresponding wavelength lambda is equal to 0, is equal to infinity. Then v is equal to infinity, lambda is equal to 0, then the waves becomes undetermined. These waves are generated by the motion of the particle. Generated by motion of the particle. Another one is matter waves are independent of charge of the particle. Charge of the particle. Waves are produced whether the particles are charged or uncharged particles. Charged or uncharged particles. The velocity of matter wave depends on velocity of the matter wave of the particle. The velocity of the matter wave depends on velocity of matter particle. The velocity of matter wave is greater than the velocity of light. The particle in motion is associated with the matter waves having two different velocity. One referring the particle, another one is wave. So E is equal to h nu, E is equal to mc square. So both the energies must be equal. H nu is equal to mc square and nu is equal to mc square by h. That is the equation 1. The wave velocity omega is given by omega is equal to frequency into wavelength. Then frequency is above equation mc square by h into lambda. So lambda is a de Broglie's hypothesis, h by mc, mc square by h, that is h by mc, h is cancelled, mc cancel, that is omega is equal to c, omega is equal to c. So omega is equal to c, the omega is equal to c squared by v. So that means here the substitution of the value, that is omega is equal to nu lambda, that is mc square by h, lambda is equal to h by mv, h cancel, cancel, that is omega is equal to c squared by v. That means the velocity of matter wave is known a phase velocity or wave velocity. Phase velocity or wave velocity. The amplitude of the finding the particle at a particular time and region. Mr. H6 నీ రోల్ నెంబర్ ప్రకారం నీ పేరు మెన్షన్ చేయమ్మా. So the amplitude of finding the particle at the particular time and region. So what is the wave packet? Wave packet is the matter waves constructively interfere is called wave packet. The matter waves constructively interfere is called wave packets. The wave packets are forming continuously from one place to another place. The matter waves constructively interfere is called wave packet. The wave packets is called a quantum. So another one is, what is the Eisenberg's uncertainty principle? In Eisenberg uncertainty principle, basically the statement, according to Heisenberg uncertainty principle, it is impossible to determine the position and momentum of the particle with all accuracy at that time. Let us consider the particle mass is m. And the moving with velocity is v along the x direction. According to classical theory, this moving particle will have a specific position and momentum at any time. That is, its position is given by x, and with respect to momentum is p is equal to mv. Relating the position and momentum, you get x is equal to p by m into t. That is called x is equal to p by m into t. So it is clear that the time t, the particle position and momentum can be measured accurately. So Eisenberg uncertainty principle is the result of a dual nature of de Broglie. It is proposed by Eisenberg in year of 1927. According to de Broglie, the matter waves associated with the moving particle superimposed over a certain region is called wave packet. The probability of the finding the particle inside the wave packet is maximum. So according to Eisenberg uncertainty principle, if the wave packet is a smaller one, then we can find the position of the particle with accuracy, but cannot determine its momentum with all the definiteness because the particle moves with a large velocity. If the wave packet is sufficiently large, then the momentum of the particle can be found. The particle moves with less velocity, but we cannot locate its position with the maximum accuracy. So hence delta x and delta p are the uncertainties in measuring the position and momentum of the particle inside the wave packet. Then according to Eisenberg uncertainty principle, delta x dot delta p is very much greater than h cut by 2. Here h cut is equal to h by 2 pi. Then delta x dot delta p very much greater than h by 4 pi. So here it is called the small position, that is called the position. Position is delta x and delta p is a large, delta x is small. But here it is called the delta x is large and delta p is a small. They cannot accurately position cannot find from here. It abruptly changes from position and momentum in continuously. If delta x is a large, delta p is a small, the same relation can be applied the energy and time, angular momentum and angle. Also, if delta E and delta T be the uncertainties in energy and time respectively, delta E dot delta T greater than or equal to h cut by 2, delta E delta T h cut by 4 pi, h by 4 pi. And similarly, angular momentum and angle, uncertainties of the angular momentum and angle, delta J dot delta theta greater than or equal to h by 4 pi. Some of the applications of Eisenberg uncertainty principle, the bonding energy of electron can be calculated. The frequency of radiation of light from the excited atom can be also calculated, and the radius of the first orbit in hydrogen spectrum also calculated. So these are all the applications of Eisenberg uncertainty principle.